Good evening, everyone. So it's Harish. I am a PhD student at ISER Mohali. So I will be conducting your live sessions for this course on each Friday from 6 to 7. So am I audible to everyone? Sanjay and Brian.
Your volume is bit too low actually.
Okay, so maybe I can use the headphones. So you are taking lectures regularly?
Yeah, I'm following up the lectures.
Okay. So how is it now, Sanjay? Is it better?
Yeah, it's better now. Thank you.
Okay. So we will be solving previous year assignment problems. So I expect that you guys come up with your own solutions and we will discuss and try to make it a two-way interaction session so that you can benefit in a better way. Uh, so it's already 6:02. So I think we can start. Others will join. So is my slides visible to all of you? My writing pad? Uh, is it visible? Sanjay, uh, can you hear or can you see the screen?
Yeah, it's visible.
Okay.
We typed out in chat actually.
Okay, so I won't be able to see the chats. So you can turn your mic off whenever you want. Padmavati, your mic is on. So maybe you can mute it. Thank you. So I hope you guys have already understood the definition of permutation and you know these symbols, what is S4 and in general what is Sn and what is mean by sigma of 1 and sigma of 3. So, but just for recalling, see, here permutation is 4213. So what does this mean? So it is your sigma is 4213. So at first place you have 4, which means as per the definition, sigma of 1 is 4. At your second place we have 2. So sigma of 2 is 2. Sigma of 3 is 1. You can see at third place it is 1. And sigma of 4 is 3, right? The question says consider the permutation sigma 4213 of S4 means the group of permutations in 4 symbols. And we need to calculate what is the value of sigma 1 plus sigma 3. So it's obvious from whatever I have written that sigma 1 is 4 and sigma 3 is 1. So what answer you guys expect? 4 plus 1 it is 5, right? So option B is correct, that is 5. Okay, so it's an easy question to start. So the value of sigma 1 plus sigma 5, oh sorry, it is sigma 3. How can I write 5 when there are only 4 symbols? Okay, so this is going to be 5. Okay, so let's uh, go to the second question. It says that a fixed point of a permutation Sn is an element I belongs to this set N uh, such that sigma I is equal to I. How many permutation of S4 contain 1 as a fixed point? So a fixed point is nothing but a point which is fixed by a permutation, means it is not moved to anywhere else. So it says that we need to find all permutations of S4 such that one is fixed. So any guesses or any ideas from your side? Any one of you can speak up, or if, yes, any quick guesses maybe?
6.
Six. Yes. And how you come up to that?
I mean, we have three slots. Like one is fixed. We have three possible slots, and like it's 3 into 2, 3 factorial.
Yeah. So it says that see okay, I will just follow whatever you said. So let's think of it like a tray with four symbols. Okay. And the first slot is fixed because they are saying that one has to be fixed. But the three slots are still vacant and they has to be filled to be filled by 2, 3, and 4. Okay. So once this first slot is fixed, it remains a permutation in three symbols. So this can be filled in any way, any through any permutation in these three symbols. So the number of such permutations is just cardinality of S3. Number of such permutations is just cardinality of S3. And you all know cardinality of Sn is n factorial. So 3 factorial, it is 6. Okay. I hope it's clear to everyone. Yeah. So let's move on to the next question. It says, what is the result of composition 3124 composed with 4231? Okay. So any guesses, or any one of you can just tell me what is the image of 1 under this composition? Let's say this
3,
is, huh?
3. Is it 3?
Is it 3? Uh, so how you make it out?
Like, like from 1 maps to 3 from the 3, 1, 2, 4. Again, 3 maps to 3. Like, it should come from left to right or like right to left?
It's from right to left.
Right to left, right?
Ah,
Okay, okay. Then other way around.
yeah, so you want to change your answer, right? No problem. You can still say what is sigma compose tau of 1.
It's 2,
That's
2, 2.
2. So I won't say yes. Okay. What is sigma of, what is tau of 1? This is
4.
your
Yeah, 4. It's 4, I think.
tau of 1. This is tau of 2. Uh, this is tau of 3, and this one is tau of 4. Okay. So sigma of tau of 1. So tau of 1 is 4. Now sigma of 4 is Yeah, now it's easy, right? I have revised the definition again. What is sigma of 4?
4 4.
Yeah, so 4. Now can you guess which option is correct? Just from this information, I think you can guess the option. Yes, anyone? Everything is
F-
written.
First option.
Yeah, first option, because all other options have some different symbols at the first place. So if you just want to tick an option, then the value of 1 itself give you the answer. Okay, so sigma of 4 is 4. So from here itself, we can say that 4, 1, 2, 3 is the correct option. But just for the sake of practicing, uh, you should check other entries also, that what is sigma compose tau of 1 and what, sorry, sigma compose tau of 2, sigma compose tau of 3, and so on. Okay, so this is this I am leaving to you guys. Okay, should be easy. The answer you already know. The final permutation is there. It's all about verifying things. Okay, so let's move on to the next question. So yeah, what is the inverse of permutation 2, 3, 1? So inverse is something with which if you compose the permutation, you get the identity again. So it's like reversing a process. Okay, so let us first write what is. Uh, yeah, is there any quick guesses? There are some chats. I won't be able to
It's
see your chat.
312.
It's 312. Okay, so let's verify all. Brian, thanks for your response. Oh, you have already written in chat. Yeah, so sorry, I couldn't see. Uh, Gokila, your mic is on, so it would be great if you can mute yourself.
Sir, I can't hear.
Your mic was on, so it would be great if you could just mute yourself. Okay, now it's okay. Uh, okay, one person has now switched on his video. Krishna, please turn off your video. Okay. Okay, so let's see if Brian is correct or not. So sigma is 231. So sigma of 1 is 2, sigma of 2 is 3, and sigma of 3 is 1. So to reverse it, we want something sigma inverse of 2 should be 1, sigma inverse of 3 should be 2. See, I'm just reversing these things. 1 is mapped to 2, so I want sigma 2 should be mapped to 1 in inverse. 2 is mapped to 3, so 3 should be mapped to 2. And here you will get sigma inverse of 1 to be 3. So it's sigma inverse is at first place you will have 3, at second place you will have 1, and at third place you will have 2. So yes, Brian, you was correct. 312 is the correct answer. Okay. So is it clear to everyone, or anyone else has any doubt? Yeah. Someone with Redmi. I don't know why you have switched on your video. You may turn it off. Please mute yourself and switch off your videos. That would be great. So, if it is clear to everyone, then we can move to the next question. Okay. So, uh, so a new definition for you guys. So, a descent of a permutation sigma of n is an integer from uh, 1 to n minus 1 such that sigma of I is greater than sigma of I plus 1. So, the image of the I is greater than its uh, succeeding one. How many descents are in the permutation 3, 4, 2, 7, 1, 5, 6? So let me write this permutation more clearly. So it is 3, 4, 2, 7, 5, 1, 6. So sigma of 1 is 3. Okay. So, and sigma of 2 is 4. So is 1 a descent or not? Anyone? Is it a descent? See, this is greater, right? Sigma of 2 is 4, it is greater. We want the other way around. So clearly 1 is not a descent. What about 2? Sigma of 2 is 4 and sigma of 3 is 2, right? So sigma of 3 is greater than sigma of, sorry, the other way around. Sigma of 2 is greater than sigma of 3, right? Sigma of 2 is 4 and it is 2. So 2 is a descent. So is there any other descent you can see? Anyone want to comment or say something?
Sigma 4 and sigma 5.
Yeah, sigma 4 and sigma 5. So for sigma 4, you have sigma 5 to be smaller than sigma 4. So it is a descent. Good. And for sigma 5, you have sigma 6 to be smaller than sigma 5. So it's also a descent. So we have three descents till now. Is there anything else or that's all? So that's it. There are no more descents. Sigma of 4 is greater than sigma 3. Okay, and sigma of 5. Oh, I'm making these mistakes again. This is sigma of 5 and sigma 5 greater than sigma 6. So this implies 2, 4 and 5 are descents. The correct option is 3. Okay. Okay. So let's move to the next question. Okay, so just a small change in the existing definition. Now, in the previous definition, we don't have n in the picture. We just choose some index from 1 to n minus 1. But now we want to include n. But see, there is nothing like n plus 1 here. So just to include that, what we say, कि a cyclic descent of a permutation sigma of n is an integer from 1 to n such that sigma I is greater than sigma I plus 1 if I is less than equal to n minus 1, or if it is n, then it is greater than 1. So it uh, goes back to 1. So for n, you need to check what is the comparison between sigma n and sigma 1, and for all other, you need to check which one is greater, sigma I or sigma I plus 1? Just a small change in the definition. So it's saying that which of the following sets may occur as the set of cyclic descents of a permutation S5. Okay, so yeah, so which option you think should be correct? It's the most interesting question in the entire assignment, that I can tell you. So can it happen कि so I will start with the last option. Can phi be the set of cyclic descent? It is it possible that we can have phi as a set of cyclic descent? Means nothing is a descent. So let's see. If it is so, then what? Sigma of 1 cannot be greater than sigma of 2, right? Otherwise 1 will be a descent. Sigma of 2 cannot be greater than sigma of 3. And anyway, their image cannot be equal because sigma is a bijection, right? So if it is not greater than, then it has to be less than. So sigma of 3 has to be less than sigma of 4, and it has to be less than sigma of 5. And then sigma 5 is also not a descent, then it has to be less than sigma of 1. So is it possible that sigma of 1 is less than sigma of 1? This inequality implies that, right? So which is a contradiction. So we have ruled out one option. Still three are there in picture. One more case is very much similar to this. Can anyone tell me straight away that uh, whether the third option can be a set of all cyclic descents or not? Yeah, anyone?
No,
What if every, yeah, no. Why?
because we'll get similar like sigma 1 is greater than sigma 1, something like
Yes,
this. Same
very good.
contradiction.
Yes, so we can't get. So just for the sake of completion, I am writing it. Someone is, I don't know, someone from your side has just did this, has written something on the screen. I don't know why. So let us continue. So can it be the set of cyclic descents? So through the same reason, if it is so, then sigma 1 has to be greater than sigma 2, and so on to, you will again get sigma 1, which is a contradiction. Okay. Now what about other two options? 1, 2, 3, 4. Can any one of you just say whether it's possible or not, or if it is possible, what's the permutation? See, we need sigma of 1 to be greater than sigma of 2, which has to be greater than sigma of 3, and then it's greater than sigma of 4, right? And 5 is not given here. So let's go
Five,
with the
four,
obvious
three, two,
choices.
one.
Huh?
Is it 5, 4,
So
3, 2, 1? Is one of the permutation.
yes, exactly. So it's 5, 4, 3, 2, and 1. This permutation will give you 1, 2, 3, 4 as a set of cyclic descents, right? You can see that sigma 1 is okay. There should be one more relation because 4 is also a cyclic descent. So sigma 4 has to be greater than sigma 5. Okay, so that's why we missed one symbol here. So it's the unique permutation with cyclic descent as 1, 2, 3, 4. You all agree to that, right? Because if you change any one of the image, then this condition would be satisfied. So this is the unique permutation for which 1, 2, 3, 4 is the cyclic descent. Okay? So there can be cases where only one permutation exists. You have already seen two cases uh, where no permutation exists with that set as a cyclic descent, set of cyclic descents. Now let's see what 1 to 5. What's true for 1 to 5? So 1, 2, and 5. So we need simply uh, sigma of 1 to be greater than sigma of 2 greater than sigma of 3. This will make 1 and 2 as cyclic descents. And then we need sigma of 5 to be greater than sigma of 1 to achieve 5, to include 5 in the set of cyclic descents. So what does this implies? This implies that sigma of 5 has to be greater than sigma of 1, and that has to be greater than sigma of 2, and then it's greater than sigma of 3. Yeah. So what can be the choices for sigma 5, sigma 1, sigma 2, sigma 3? Anyone?
The total permutation can be 3, 2, 4, 5. 3, 2, 1, 4, 5.
3, 2, 1, 4, 5. Okay. So first choice is you can take it as 4, take it to be 4, it to be 3, it's 2 or 1 and 1, or you can take it 5, means I'm saying its value 5, then sigma 1 to be 4, then sigma 3 to be 3, and sigma 3 to be 2, right? So let me just add one page here. Just mm, yeah. Sorry for the interruption. Yes. So sigma can be at one place you have if the going through the first case it is 3, 2, 1, 5, 4, right? Or the second case gives us uh, 4, 3, 2, 1, and 5, right? You will agree to that? There are two permutations uh, which can have 1 to 5 as the set of cyclic descents. Okay, so that completes this question. So option 1 and 2 are correct, and the rest two are incorrect.
I have a question
Yeah,
there.
yeah.
In the last two solutions, what you wrote,
Hmm.
32154, right? In that sigma 4 is a descent, right?
No. Sigma 4 is less than sigma 5, right? You need sigma 4 to be greater than sigma 5.
Okay.
Correct? See, once you satisfy this condition, uh, okay, there is some. Here you are saying that sigma 4 is also a descent. Here, uh, okay, okay. I got your point. So this set has uh, sigma 4 as a descent
Yes, yes.
because sigma 4 is greater than sigma 5, and here it is okay, but here sigma 3 is a descent, cyclic descent.
Yes.
Yeah, so we have to come up with some other choice.
32145 satisfies it. Just can you
Okay,
check?
so you are saying 3, 2, yes,
32145.
1, 4, and 5. So 1, 2, okay, 3 is not there, 4 is not there, 5 is also there. Okay, so which means that to satisfy this condition, there is one more choice that you can take 5 here at the place of 1, you can take 3, and you can take it 2, you can take it 1, right? So in this case, these are not possible because here sigma 3 is greater than sigma 4, and here you have sigma 4 to be greater than sigma 5. So we don't want 4 and 3 to be included in the set of cyclic descents. So that's why sigma is equal to 3, 2, 1, 4, 5 is the correct permutation for which you will get 1 to 5 as a set of cyclic descents. So is it Sanjay, right? You gave the right solution.
Yeah, it's Sanjay.
Okay. Thanks, Sanjay.
Welcome.
So now we have a numeric answer type question. What is the unique permutation in one like notation of S3 whose cyclic descent set is 1, 2? Anyone else? Others can also speak, or if you're not comfortable with speaking, then you can write in the chat. Now I'm also looking at the chats. No one? Okay, then. And I have to do the hard work again. So what does this condition gives? We want 1, 2 as the set of cyclic descent. So sigma 1 has to be greater than sigma 2, and for 2 to be a cyclic descent, we want sigma 2 to be greater than sigma 3. Now you have three symbols, you have these relations. What is the obvious choice for sigma?
321.
Yeah, 3, 2, 1. All All of you agree? At least write it in the chat that you agree or disagree or you have any doubts so that we can repeat if someone wants. No responses. Okay, then I assume you all are here and awake. So let's move to the next question. An inversion of a permutation of sigma of Sn is a pair of integer ij such that I is less than j but sigma I is greater than sigma j. So as the name suggests, it inverses the role once you apply sigma. So I is less than j but sigma I is greater than sigma j. So how many inversions does the permutation 32415 have? First of all, can you find at least one inversion? You need to give me a pair I comma j such that sigma I is greater than sigma j. There are plenty of such I can tell you, but let's first uh, get your answers. How many you can get? You can write it in the chat as well. You can speak up. Whatever way you want to respond, you can do.
And 3, 2 is one pair.
3 2 is one pair. Okay, so sigma 3 sigma 3 is greater than sigma 2 na. We want I greater than j, then sigma I has to be less than sigma j. First of all, see, if you are pairing something, then the first index should be the smaller one. 3 2 doesn't make sense as per the given definition. I has to be less than j. So 2 3 makes
It should,
sense.
it should have been 1, 2. Sorry.
Okay. 1 2. Oh, so you were just saying the images. Oh, 1 2 is correct. Yeah. 1 is less than 2, but sigma of 1 is greater than sigma of 2. Okay. So at least one person is awake. So he's saying that 1 2 is an inversion. Why? Mm, because sigma of 1 is greater than sigma of 2, which is 3, and here you have 2, right? So is there any other inversion with 1 as the first element? 1 comma something. See, 1 is always 1 is the smallest index. So if you find anything which is smaller than the image of 1, then that has to be the part of inversion, right? So sigma 2 has 2, which is
1
smaller
comma
than
4.
sigma. Yeah. So 1 4 is also an inversion. Is also an inversion because sigma 1 is greater than sigma 4. This is 3 and this is 1, right? Can there be anything else? Yeah. No, right? Because
2
now you
comma
have
4.
only two. Huh?
2 comma 4.
Yeah, you are changing the first index. That's fine because now there won't be any other pair with 1 as the first index. You are saying 2 4. So I am believing you. So sigma 2 is there. Yes, because sigma 2 is 2, sigma 4 is 1. Okay. So definitely there won't be anything starting with this 2 because the image of 2 is 2 and we already have a index with which is greater than 2 and has sigma I to be smaller. Now, is there anything starting with 3? Yes.
3 comma 4.
Yeah, 3 comma 4, right? I don't know why the others are not responding. It's very easy. Uh, we're not doing some complex mathematics. It's going very smoothly, I guess. So if sigma 3 is 4, I repeat, if you're not comfortable with speaking, you can also write it in the chat. Okay.
3 comma
So
5.
3 comma 5. So let's check whether 3 comma 5 is a pair, is an inversion. So 3 is less than 5, that's okay. But what is sigma 3 greater than sigma 5? Sigma 3 is 4, right? You can see here 3, 2, 4. So at third place it is 4 and at fifth place it is 5. So 2, uh, this is not true, right?
So, okay.
So, okay, so 3 comma 5 is not an inversion, is not an inversion. And once you started with 4, then there is only one possibility to you need to check because we are already assuming that uh, I has to be less than j. So is sigma 4 greater than sigma 5? So sigma 4 is 1, sigma 5 is 5. So that's not true, right? So 4 comma 5 is also not an inversion. How many inversions you got? 1 2, 1 4, 2 4, and 3 4. So 4 inversions, right? The correct answer is 4. Okay. Let's go to the next question. What is the most inversions a permutation of S5 may possesses? Yeah. So this will test your combinatorics, uh, how good you are with counting. So we have seen an example above of S5, uh, right? 3 2 4 1 5 is a element of S5. It has 4 inversions. So definitely your answer has to be greater than equal to 4, which is all obviously these 4 options also suggest you don't achieve anything by observing the last uh, question directly, but yes, still you can make it out. So Gokila, can you please mute yourself?
I don't know.
Can you just mute yourself? For most inversions, you you should have sigma 1 to be 1 is less than 2 definitely and 3 so on. So sigma 1 has to be greater than everything, right? It has to be greater than sigma 2, sigma 3, sigma 4 and sigma 5. And sigma 2 has to be greater than sigma 3, 4 and 5, and again sigma 3 has to be greater than 4 and 5, and sigma 4 has to be greater than sigma 5, right? Do you all agree that for most inversions we should have this condition?
Mm.
See, we want the number of inversions should be maximum. So if we want to take our I, the first index to be 1, then sigma of I has to be greater than everything that it follows, 2 sigma 2 sigma 3 sigma 4 and 5, and similarly with any index, right? So this condition must be satisfied in the case of most inversions, and that we have already seen that this is true only when sigma is 5, 4, 3, 2 and 1. And what does this implies? That whatever you choose after 1, that's an inversion for sure. So 1 2, 1 3, 1 4, 1 5, these are inversions. And then after 4, whatever number greater than 2 you choose, that's going to be an inversion through whatever we have already chosen. Okay. And then if we are starting with 3, then 3 4, then 3 5, and at last 4 5
4,
are,
5.
yeah, all inversions. So total number is 10. So you can have maximum number of inversions to be 10. Okay. So if it is clear to everyone, then we will move to the next question. If you have any doubt, then you can ask. Okay, so let's move to the next question. This question says a cycle of length k or k cycle in a permutation sigma is an ordered collection I1 to Ik of elements of this indexing set 1 to n such that sigma ij is ij plus 1 for j equal to 1 to k minus 1 and sigma ik is I1. Which of these permutations contain a 3 cycle? So let's first discuss what is a cycle. So cycle is a permutation of this form. Let's say we are starting with something whatever 3 4 3. This is a cycle of n. So this is a cycle if sigma of ij means sigma of 3 is 4. Oh sorry, we can't have two symbols same because it's a permutation. So let's say 3 4 6 maybe, or 2. Sigma of 3 is 4, sigma of 4 is 2, and sigma of 2 is 3. So uh, we say that it's a cycle if sigma maps these elements in such a way. So this will imply that 3 4 2 is a cycle. It's just a example we are discussing. Example of cycle. Okay. Now come to the solution part. It says that which of these permutation contains a 3 cycle. So let's see the first one, 2 1 3 4. Here you have sigma of 1 to be 2 and then sigma of 2 to be 1. So it's a 2 cycle, right? 1 2. It has a 2 cycle. It's not a 2 cycle. It has a 2 cycle. Okay. And sigma of 3 is 4 and sigma of 4 is, oh sorry, sigma of 3 is 3 and sigma of 4 is 4. So it contains a 2 cycle but not a 3 cycle. Okay. Cycle means it's just a circular images you can say you have. Okay. So the second one, 2 3 4 1. Sigma of 1 is 2, sigma of 2 is 3, sigma of 3 is 4, and sigma of 4 is 1. So here you have 4 cycle but again not a 3 cycle. Then the third one is 2 4 3 1. 2 4 3 1. So sigma of 1 is 2, sigma of 2 is 4, sigma of 3 is 3, and sigma of 4 is, see, image of 1 was 2, image of 2 was 4, and image of 4 was again 1. So it is a 3 cycle, right? So it's a correct option. These were not the correct options. The fourth one is 1 3 2 4. 1 3 2 4. Sigma of 1 is 1, sigma of 2 is 3, sigma of 3 is 2, and sigma of 4 is 4. So 1 is fixed at 1, 4 is fixed at 4, 2 is mapped to 3, and 3 mapped to 2. So it's a 2 cycle, but again it does not contain a 3 cycle. So only option third is correct. So we are running out of time. So I will just try to wind up the things. At any step, if you see that some doubt is there, or you're not getting something, then please speak up or write it in the chat. So it says a permutation may be written in a cyclic decomposition notation as a list of its cyclic cycles. Which of the following are cycle decomposition of permutation 3 6 4 1 2 5? So this you have to check through the images. See, sigma of 1 here is 3, right? So here sigma of 1 is 3, 1 is mapping to 3, okay. 1 is mapping to 3, that's also okay. But here 1 is mapping to 3 and 1 is mapping to 3. So sigma of 1 won't cancel any option. Now sigma of 2 is 6. Sigma of 2 is 6 here. Here sigma of 2 is 2. 2 is fixed at 2. So this option won't be there. Here sigma of 2 is 6, sigma of 2 is 6. So we are able to cancel out one option through sigma of 2. Now sigma of 3 is 4. So sigma of 3 is 4 here. 3 is mapping to 4, 3 is mapping to 4, 3 is mapping to 4. So again, no cancellations. Sigma 4 is 1. 4 is mapped to 1 in the first, in the second, in the third. But in the fourth, 4 is mapping to 2. So this option is also not correct. Now we are left with the 1 and the first and the second option. Okay. So 1 in the first and the third option, sorry. So where we were, sigma of 4 was 1. Sigma of 5 is 2. Sigma of 5 is 2 here. 5 is 2 here. This is also correct. Sigma of 6 is 5. Sigma of 6 is 5. So it is definitely correct. And here sigma of 6 is 5. So this is also correct. So first and third options are correct. Rest two are different, not correct. You just need to check the images. It's not something complicating. It's very easy. Just check the images. You will get the answer. Okay. So a permutation of Sn is called a cycle if there is a single cycle in its cyclic decomposition. How many cycles are in Sn? So here there is a typo. How many n cycles are there in Sn? You need to find them. Okay. So see, you need to find an n cycle. There are n places in this cycle. So once you start with 1, it cannot be mapped. Sigma of 1 cannot be 1, right? Because if sigma of 1 is 1, then the cycle will close here. It won't go ahead. So it has n minus 1 options, n minus 1 choices. And say sigma of, let sigma of 1 is something j, which is greater than 1. Then first element you can choose arbitrary, because cycles you can shift in a cyclic order. What does I mean? That 1 2 3 is same as 231, right? Because that won't change the image. So you can, uh, as long as you are making changes in a cyclic order, 231 or say 312, the image won't change. So you can uh, by default start with 1. Okay, so that's what I'm doing here. I am starting with 1. Now 1 has to be mapped something somewhere else if it's an n cycle. So it has to be something greater than 1. Now sigma of j. Sigma of j cannot be equal to j first of all, because it will uh, terminate the cycle, and sigma of j cannot be equal to 1 also, because if it is the case, then 1 mapping to j, j mapping to 1, the cycle will close here, it won't go till n. So it has n minus 2 choices, right? So going like this in the similar pattern, you will find that there are n minus 1 times n minus 2 times n minus 3, so on to 1, that is n minus 1 factorial number of choices. I hope the idea is clear to everyone. Let's move on to the next question. It says that S is A1 to AK be a subset of this indexing set. The symmetric group acts on S in this way that sigma acting on S will uh, give you the set sigma of A1, sigma of A2, so on to sigma of AK for every sigma belongs to Sn. Now consider this permutation sigma to be 2, 1, 4, 5, 3, 6, and 7. How many subsets of this 7 are fixed, that is sigma dot s equal to s by sigma? So it's a tricky question. It's saying that with this permutation sigma, how many subsets are there which will be fixed? So uh, I will just say कि let's first see the cycles in sigma. It will definitely help you, because cycle is a subset that will be fixed, because uh, you will realize soon, as soon as we start computing the cycles, you will realize soon why I am starting with the uh, exploration of these cycles. So see, 1 2 is a cycle, 1 is mapping to 2, 2 is mapping back to 1, so 1 2 is a cycle. Then 3 is mapping to 4, 4 is mapping to 5, and 5 is mapping to 3. So 3 4 5 is a cycle, and 6 is mapping to 6, so it's a single cycle, you can say. And 7 is also mapping to 7, right? So it's a cycle decomposition of this sigma, right? You all agree that sigma is 1 2 3 4 5 6 and 7. So if you take any cycle as a subset, any subset with the index of a cycle, then that subset is always will always be fixed by this sigma. So if you take the subset 3 4 5 and act sigma over it, then 3 4 5 subset will be mapped to 3 4 5, right? Because these symbols are just get permuted with each other. 3 is mapping to 4, 4 is mapping to 5, and 5 is again mapping to 3. So this subset won't be mapped to any other subset, right? So if you take any cycle, then that's definitely a subset which is going to be fixed by this sigma. And even if you take a union of it, then that will also be uh, so union of, how to write this. So union will also be fixed, and definitely the empty set will always be fixed. So just realize this statement, whatever I am writing. If number of cycles in sigma is say k, then the number of such subsets is 2 raised to k. Okay, so why I'm saying so? So let t be the set. Okay, maybe I can write it here. Some of you might have realized why I have written this. If it is not clear, then let me clarify it. So let T is the subset containing all uh, elements which are in cycle type. So 1, 2 is there. So I will just write 1, 2 as a subset. 3, 4, 5 is a cycle. So 3, 4, 5 as a subset. 6 as a subset and 7 as a subset. So if this is a set, uh, T is this, then any element of power set of T will satis- will be fixed by sigma. Okay, because if you take any union of these subsets, then that will also be fixed. If you take uh, the empty set, then that is also fixed. If you take the entire set, then that is also fixed. So any element of P of T will be fixed. So that's why here the uh, cardinality of this T is k, the number of cycles. Okay, and it has cardinality. This set has cardinality. You all know that power set of something has cardinality to be 2 raised to cardinality of t, which is 2 raised to k. Okay, so that's why here you have 4 cycles. Here k is 4, thus 2 raised to k, that is 2 raised to 4. Number of such subsets is 2 raised to 4, that is 16. Okay, so we have already exceeded the time limit, but let's quickly see the last question. The cycle type of a permutation is permutation sigma is denoted in the exponential notation as 1 is to sigma 1 of a1 sigma. So a1 sigma means the number of uh, mm, cycles of length 1, and a2 sigma is number of cycles of length 2. Okay, so cycle type is denoted as this: 1 raised to a1 sigma, 2 raised to a2 sigma, and so on, where the only numbers I with non-zero AIs are enlisted. So if AI sigma is 0 for some I, then we won't list that. The cycle type of permutation 2735461 is this. Which of the following permutation have the same cycle type as this permutation? So you can check that number of cycles in 2734 35461 of length 1 is 2, length 2 is 1, and length 3 is 1. We need to check that which permutations have the same cycle type. So I'm just giving you the answer. So 2154637, this option is correct, the second one, and 2637514, the third option is also correct. You can check that these uh, permutations have the same cycle type. So just try to figure it out of your own. If that's uh, if you find any difficulty, then we can discuss it in the next interaction session. So next interaction session will be on the next Friday through the same Zoom link. Okay, so there was a small confusion. We had a Gmail link also, but now it's been changed to the Google Zoom link. So okay, that's it. I hope you guys enjoyed it. But next session will be uh, in the next session we will discuss assignment 2 of the previous year course structure. So just go through that once so that we can have a two-way interaction. Okay. Any quick doubts? Yeah. Is someone awake? Just to say me goodbye, sir, or thank you, sir, or we will meet again, sir, so that I
Thank you,
can
sir.
see that people are still awake.
Yeah, no doubts. We'll see you next week.
Okay, so Sanjay, you are awake. At least I can say throughout the session. I don't know about others. So, is there any issue? Means I can't understand. People were not writing in the chat as well. So, is everything was going above your head, or you were getting at least something? See, just take it as a class. We will have a regular interaction. So, it would be great that if we have a two-way interaction. I asked you to switch off your videos just because your uh, username doesn't flash in between the recording. That's it. Otherwise, you would have a class like environment with videos on and having some chit chat and then trying to sort solve the problems together. But just for the technical reasons, I suggested that you should switch off your videos. But still, try to be interactive. I will say. So you are getting everything in class. You can also ask me the doubts from the class. I have no problem in sorting out it. Just take it as your private tuitions. You can ask me whatever you want to ask related to the course. Okay. Okay. So if there are no other doubts, then I think I can leave. If you want to ask something, then you can do now, or you can also leave.
Yeah, thank you, sir.
Okay. Thank you, Sanjay. There is something in the chat.
Thank you, sir.
Thank you, Gokila. I hope I pronounced your name correct. It's Gokila, right?
Yes.
Okay.
Okay.
Okay, then. Bye bye. We will meet again the next Friday from 6 to 7 on the same Zoom link. Okay. See you.